Hello everyone and welcome back to The Explainer. If you're a focused learner looking to finally demystify exactly how we communicate with artificial intelligence, well, you are in the perfect place. Today, we're taking a really fascinating journey. We're going to start from the absolute basics of talking to AI, and we're going to build all the way up to designing enterprise-grade systems. Seriously, we're going to fundamentally change how you view that little text box on your screen. So get comfortable, keep your eyes on the screen, and let's get started with mastering the input, the engineering behind AI. Okay, let's dive right into this. We have all been there. You type what you think is a perfectly reasonable request into an AI system, and you get back something that's just completely unhelpful. It's incredibly frustrating, right? The immediate reaction is almost always, well, the AI isn't giving me what I need. The AI is broken. But here is the core thesis we really need to embrace today. The AI isn't broken. Your instruction is. It's literally doing exactly what you asked it to do. The gap between what you want and what you get, that isn't a glitch. It's an engineering problem.
And this brilliantly illustrates exactly what I mean. Notice the totally chaotic output you get from a vague request like, summarize this document. Sure, that might work for a quick one-off demo, but it returns a massive, unstructured paragraph that's different every single time you ask. It's totally unusable in a real professional workflow. Now, compare that to an engineered instruction. You are a legal analyst. Summarize in 3 bullet points, key claim, risk, recommended action. Think of the AI like a highly eager but incredibly literal intern. If you just say summarize, they're going to just guess what you want. But if you give them a specific role, a structure, and a clear extraction target, they will deliver a perfect, reliable result every single time.
To really understand why this happens, we have to look at the foundational reality of what these systems actually are. Underneath all the perceived magic, language models operate on a core mechanism called next word prediction. They're essentially mathematical engines calculating the most likely subsequent word based entirely on the input string you provided. They don't magically understand your unstated goals. Therefore, if your prompt is vague, the mathematics basically guarantee an unpredictable, scattered prose. You have to make the model's life easy by guiding the math.
Yes, and that leads us perfectly into the operational machinery of this whole process. We've seen the big picture, kind of the beginner's view of why the input matters. But if you're using this in your daily professional life, you need a framework. You need to know exactly how to construct that input so it stops being a random gamble and starts being a guarantee.
Now, what's really interesting about this slide is the exact anatomy required to build a reliable instruction that works every single time. These are the 4 pillars of a production-grade prompt. First up, role. Who is the model? A senior financial analyst? A friendly customer support agent? Second, task. What is the specific action it must perform? Third, context. What does it need to know about the situation that isn't immediately obvious? And fourth, format. Exactly how should the output look? Are we talking a strict data format, a clean table, or maybe a 3-sentence email? Now, not every prompt needs all 4, but if an output fails, it's almost always because one of these pillars is missing.
Which brings us to the golden rule of troubleshooting. When professionals get a bad output, actually, let me rephrase that. When anyone gets a bad output, the instinct is often to delete the entire prompt and just start typing from scratch. Don't do that. Use this 3-step process instead. Look at the bad output and ask, did it lose the tone? Okay, I need to fix the role. Did it give me a paragraph instead of a list? I need to fix the format. You diagnose the single missing pillar, refine that specific component, and then retest. It's a surgical approach, rather than just taking a sledgehammer to it.
Let's look at how we apply this anatomy across different frameworks. This table outlines the core patterns professionals use every day. Zero shot is your baseline, just a direct instruction, great for simple lookups. But look at few shot. This is where you provide 1 to 3 examples of the input and your desired output before asking the AI to do the task. Imagine you're transforming a chaotic customer inquiry sorter into a structured pipeline. By giving the AI 2 examples of exactly how to categorize an angry email versus a billing question, you instantly achieve massive, high ROI consistency. The model literally infers the exact pattern you want just by looking at your examples.
But what if the task isn't just sorting data, but actually making a complex decision? Well, that's where the third pattern, chain of thought, comes in. Simply telling the model to think step by step before answering is incredibly powerful. It literally forces the AI to structure its reasoning out loud before giving you the final answer. This drastically improves the model's accuracy on multi-step logic and risk analysis. Because its thinking gets structured first, the final conclusion is vastly more reliable.
Yes, And this is where we elevate our perspective from the intermediate framework up to the advanced architectural level. Because it's one thing to craft a brilliant prompt in a chat window and get a great result once. It's an entirely different beast when we integrate this into a background business system.
Just think about this number for a second. 10,000. If you build an automated system to classify incoming support tickets or, say, process invoices, your engineered prompt isn't just running once, it's running 10,000 times a day. The architectural challenge of scale means your engineered system must perform exactly the same on the first input as it does on the 10,000th. An unpredictable output at scale doesn't just ruin a fun demo, it completely breaks the entire data pipeline.
Let's move to and see how this builds into what we call harness engineering. At the enterprise level, the prompt is really just the engine. Harness engineering is the entire robust car built around it to make the AI truly autonomous and safe. You need memory systems so the AI remembers past interactions. You need routing logic to automatically send complex tasks to larger models and simple tasks to smaller, cheaper ones. You absolutely need strict output validation to ensure the AI doesn't break your database with weird formatting. And finally, you need feedback loops to monitor performance. This is exactly how you take a raw prompt and turn it into a bulletproof software architecture.
And how do advanced strategists actually know their harness and their prompts are bulletproof? They turn gut instinct into defensible data. They don't just type a prompt, look at the answer and say, yeah, it looks good to me. No. They use open source evaluation frameworks. They write automated test cases to find exactly what a correct answer looks like and run their prompts against hundreds of rigorous data points. This provides measurable, defensible metrics on consistency and accuracy. It is literally the difference between guessing and knowing.
So the crucial point is this profound mindset shift. Think about it. The underlying AI model, the raw technology itself, is increasingly becoming a commodity. Models update, they change, new ones are constantly released. But the asset, the true, lasting business value, that is your engineered instruction. If you build a flawless, highly optimized prompt architecture using the frameworks we've discussed today, that intellectual property belongs to you. It's portable. If one AI model gets updated or deprecated, your engineered asset remains perfectly intact, ready to be plugged right into the next one.
Which brings us to our final, overarching thought for today. Whether you are just typing your very first request into a chat box, or you're a senior architect designing an automated system handling tens of thousands of tasks, this single truth unites us all. Mastering the input is the only way to master the output. It is not magic, it is engineering. So, the next time you sit down to use an AI tool, don't just ask it a casual question. Treat that little text box like an engineering terminal. Apply your 4 pillars, structure your reasoning, and take total control of the output. The technology is out there, but the intellectual property is how you instruct it. So what automated empire will your very first engineered prompt build today? Thanks so much for joining me on The Explainer, and I will see you in the next one.